Good morning, 8th grade. Mr. Hale here. It is Wednesday, April 15th, and I hope you and your family are well. Today, we're going to continue reviewing cones, and specifically, we will talk about cone surface area. And the big thing to know about cone surface area is, like pyramids, which we'll talk about later this week, finding the surface area of a cone requires you to know a measurement that doesn't come up for any other shape. And that measurement is called the slant. So on our example here, number 2, 4 millimeters is our radius. That's the distance from the center to the edge of the circular base. 12 millimeters is our height. That is the distance from the floor to the peak straight up. Slant is this guy here. It also goes from the floor to the peak, but it does so by following the diagonal surface of the cone. There are a number of different symbols that are used for slant in various websites and textbooks. That symbol is never the letter S because that is used elsewhere. It's always some form of the letter L. And the symbol that I prefer to use for slant is kind of a fancy cursive L. Again, slant is the measurement from the peak to the floor along this diagonal surface of the cone, and is different from height in that height goes straight up and down. So, you'll notice that on none of these problems have I given you the slant height. So in order to find the slant height, we're going to have to do an extra calculation. So we need to go back and remember the Pythagorean theorem. A squared plus B squared equals C squared. The reason this comes up when it comes to cones and to pyramids, as we'll discover later this week, is because you can imagine that the slant here is the hypotenuse of a right triangle created by the radius and by the height. See how that green forms a perfect right triangle where what we have been calling A in our previous Pythagorean theorem problems is your height, and what we've been calling B in our previous Pythagorean theorem work is our radius, and then C is the slant from the floor to the peak along the slanted diagonal surface. So another way that we can think about this when it comes to cones is we can think about this as radius squared plus height squared equals your slant squared. Once we know how to do that, then we can move on to the full formula that will give us the overall surface area of the cone. But let's start with this. Let's figure out what this measurement, our slant, is. Okay, let's substitute in what we know. We know the radius is 4, so we replace the letter R with 4 squared. We know the height is 12, so we replace the letter H with 12, keep the squared. We don't know the slant, so we put our symbol. Now let's do our calculation. Pull up the calculator. We're going to do 4 squared plus 12 squared. That's 160. So 4 squared plus 12 squared is 160. That's equal to your slant squared. But remember, we don't want the slant squared, we just want a slant. So how do we go from slant squared to just the slant? To get rid of that exponent, we need to use, I almost did this in the wrong spot here, we need to find the square root. The square root takes away the exponent. The square root and the exponent, the root and the exponent are opposites of each other, just like addition and subtraction or multiplication and division. So by finding the square root of the slant squared, we end up with just the slant. The radical and the exponent blow each other up. But what we have to do on this side, we have to do on this side as well. That's one of the first rules of algebra. So we need to find the square root of 160. What is the square root of 160? It doesn't appear to have a square root symbol on this particular calculator. How odd. So let's remember 160, and let's go here. SQRT parentheses 160 parentheses. In Google, it'll always give you the square root. It's 12.64911, blah, blah, blah. Let's just round this off to 12.6. So we're going to say that our slant is equal to 12.6. Okay, now we have all three measurements that we need to find the surface area of this cone. Before we could even begin to talk about the surface area of the cone, we had to use the Pythagorean theorem to find the slant length. Once we have that, then we need to talk about what the formula for the surface area of a cone is. That formula is going to start with the thing that we always start with if we're dealing with a circular base. If you think back to our lesson yesterday, anytime we're dealing with a circular base, the first thing we need to do is pi r squared. That is the formula for finding the area of a circle. That will give us the area of this circular base. We're going to put that in parentheses. And then we're going to add a second expression. It's going to start very similarly. It's going to still be pi times radius, but this time we're going to multiply by our slant. So we're going to do, and there we go. So the formula for the surface area of a cone is pi times radius squared plus pi times radius times slant. And if you don't know the slant, you're going to have to use the Pythagorean theorem to find it. Let's plug in what we know from example number 2 here and see what our result is. So pi is just pi times radius squared. That's going to be, oops, I started writing down an r. What I should be writing down, because we know our radius is 4 squared. And then add that to pi times radius, which is once again 4, times our slant, which we now know is 12.6. Pi times radius squared plus pi times radius times slant. Let's pull up our calculator. We're going to do parentheses 3.14 times, what's 4 squared? 16. Close parentheses. Plus parentheses 3.14 times radius is 4 times slant is 12.6. Close parentheses. See how our whole formula is here? It equals, there's our final answer, 208.496. We're going to round this up to 208.5. What are our units going to be? Well, this is measured in millimeters. And area is always to the second power. So the surface area of this cone is 208.5 millimeters squared. All right, let's talk about an example where we don't know the radius off the top. So over here on number 1, our right triangle, there's our slant, there's our radius over the center, and then there's our height straight up and down. That's our right triangle. And we know that to find the slant, we need to use the Pythagorean theorem formula, which we're modifying here as radius squared plus height squared equals slant squared. We don't strictly know the radius on this problem. We know the diameter. I've given you on the drawing the distance from one edge to the other edge, and that's 3 centimeters. But what's the radius from the edge just to the center? The radius is always half of the diameter. So our radius is going to be half of 3, which is 1.5. So then let's convert that into our Pythagorean theorem formula. R squared, radius squared, is 1.5 squared, plus our height squared is 10, so that's 10 squared. And that will give us, let me erase that. That will give us our slant squared. Let's go to our calculator. Clear everything. 1.5 squared plus 10 squared equals 102.25. So 102.25 is equal to our slant squared. Radius squared plus height squared equals slant squared. So our slant squared is 102.25. Let's find the square root of that. On Google, you can put SQRT parentheses and then put your number in those parentheses. Looks like our answer is 10.1. So we know that our slant is the square root of 102.25. Square root of 102.25 is 10.1. So we now know that our slant, it's a terrible drawing, but you know what I mean, is 10.1. Now that we have that information, we can put it into our formula and find our answer. Pi times radius squared plus pi times radius times slant. So we need to do pi times radius squared. We know our radius is 1.5 plus pi times radius, which is just 1.5, times our slant, which is 10.1. And then we can punch that into our calculator. So clear everything. Parentheses, pi times 1.5 squared, close parentheses, plus parentheses, pi times 1.5 times 10.1. Hit equals, add them together, 54.66 and change. We're going to call this 54.7. So our surface area of this cone is 54.7. The measurements were in centimeters, and surface area is always squared. So you're going to need the radius and the height to find the slant length. And once you know the slant length, you use the formula pi r squared plus pi times r times slant. Let's do one more example here on number 3. We'll go a little faster this time. We know that this is our slant distance, the diagonal. We know that, actually I'm going to erase this and do this on the other side. We know this is our slant right here. And we know that our right triangle is formed by the radius and the height. So we're going to do radius squared plus height squared equals slant squared. The information that we have is we know the radius is 6, so 6 squared. We know that the height is 14, squared. And we use that to find our slant. All right, go to our calculator. Clear everything. 6 squared plus 14 squared equals 232. So our slant squared is equal to 232. To get rid of the squared, hold on a second, just don't want to confuse you, that shouldn't be a 3, that should be a 2. So to get rid of the exponent here, we need to find the square root of both sides. So the square root of 232 and the square root of L squared. So we just get slant. What is the square root of 232? Let's put that in our parentheses on Google. 15.2. So we're going to say that our slant is 15.2. Once we know our slant length, we can plug everything in to our formula. The first one is pi times the radius squared. We know our radius is 6, plus pi times the radius, which is 6, times our slant, which we now know is 15.2. Jump to our calculator, clear everything. Parentheses, pi times 6 squared, close parentheses, plus parentheses, pi times 6 times our slant is 15.2. Add them all together, you get 399.6. So the surface area of this cone is 399.6. Our measurements are in yards, and surface area is always to the second power. All right. As always, do your best. If you have any questions, email me or jump into my office hours this afternoon. Stay home, stay safe, wash your hands, try not to touch your face. I hope to see you all soon. Bye.